Alright, so the second derivative can be used to figure out your extreme values too. Yeah, for time purposes. Alright, so what we're going to need to do is we're going to need to come up with our critical values from the first derivative. Alright, so that's going to be setting the first derivative to 0 and coming up with those particular x values. Once you come up with the second derivative, you're going to test those critical values in the second derivative. Right? So if the second derivative is positive at that critical value, that means that your graph looks something kind of like that, right? So that means that you are concave up, right? So that means at this point here must be a relative what? Min, right? And then if that point makes it concave down, that means at that point must be a relative max. And then if you get 0, you have to, it doesn't work, and you have to go back to the first derivative test into the second derivative. Yes. All right, so you have negative 3x to the 5th plus 5x cubed. Figure out the relative extrema for that function using the first derivative test and then the second derivative test. All right, so we're going to come up with the extrema and then confirm it with the second derivative. All right, so we got f prime of x is negative 15x to the 4th plus 15x squared. All right, I'm going to set that equal to 0. I can take out a negative 15x squared, and I'm left with x squared minus 1. Right? So I have zeros at x equals 0, 1, and negative 1. Negative 1, 0, 1. So we got negative 2, negative a half, 1/2, and 2. Alright, so if you plug in negative 2, what do you get? That would be negative and positive, so that's negative. Negative 1/2 would be negative and negative, right? So that's positive. 1/2 would be negative and negative, so that's positive. And then 2 would be negative and positive, so that's negative. Okay, so what do we know is going on? Relative min, good, and then you have relative max at positive 1, right? So relative min at x equals negative 1. And then you have a relative max at x equals positive 1. Okay, good. So that's nothing new. That's from last section. So now what we're going to do is we figured out that my critical values were these values here. So what I'm going to do is I'm going to figure out the second derivative and then plug these critical values in, and it should help me determine if it's a relative min or a relative max. So what would the second derivative be? You can write it down for part B, but I'm going to do it right next to where we did part A. Part A is done. Negative 60x cubed plus 30x squared, or 30x. We go with that? All right, so we got f double prime. You're going to plug in your critical values, which are those. You can if you want. You don't have to, because we're not trying to find any like inflection values from the second derivative. We're just trying to evaluate this function and tell me if it's either positive, negative, or 0. So you're more than welcome to, but you don't have to. So if I do f double prime of 1, right, I get negative 60 plus 30, which is less than 0, right? So by second derivative test, f of x has a relative. Now, because this is negative, right, at this particular value, it is concave down, right? So that means you would have a relative max. Second derivative test, f of x has a relative max at x equals 1, since f double prime of 1 is less than 0. And right, but this is like, sometimes using the second derivative test is actually quicker than doing that thing that we just, right. Those are your critical values from part A. So that we only did this one so far. We're going to do the other two. What's that? Yeah. Yeah, so yeah, exactly. Instead of doing this, you can kind of skip right to the second derivative and then test it if you want to do it that way. Okay, so f double prime of 0 is going to give me 0. All right, now, since I got 0, I can't use the second derivative test. All right, so you'd have to go back to the first derivative and see what you get. All right, so fail. So then f double prime of negative 1 would be 60 minus 30, which is greater than 0, right? So that means that it's concave up, so that means you have a relative min. So f of x has a relative min at x equals negative 1 by the second derivative test. F double prime of negative 1 is greater than 0. Yes? Yeah. So if your function is concave up, depending on the function that they give you, second derivative might be a little bit quicker to do. You know, say if this is like a calculator question, and they were to say, all right, figure out for me the relative extrema. You know, if you could come up with the extreme values and then just plug all these values into the second derivative, it'll be a lot easier than maybe doing the sign chart. So it's all about options. All about options. All right, what do I want to do? Okay, what I want you guys to do for the next couple of minutes, get into groups and see if you can come up with the answers to number 7.